Hello, hi, guys. So, welcome to my YouTube channel. Hello, BG. So, today we will read and we will solve the problem of count square some triples. Right? In that problem, I just read about like in that we just have to a square triple ABC is a triple where A, B, C are integer and A square plus B square is equal to C square. Given an integer and return the number of squares triple such that 1 greater than A, B and C greater than N. Right? So in that questions says like N is equal to 5. Right? N is equal to 5 and in that I just have to find uh, like 1 2 3 4 and 5, right? In that we just have to take of two data which is equal to the third integer, right? So if we pick 1 1 into 1 is equal to 1 and 2 into 2 is equal to 4, which means 5, right? 5 and and in that any of the data is not the mm, any of the data is not equal to the 5, right? Like 5 into 5 by 25, so there is no. So now we just have to come uh, to the next. We just found the next one. So we just see 3 4 and the 5 and 4 3 and 5, right? So in that we see like 3 into 3 is equal to 9 plus 4 into 4 is equal to 16. So what is 16 plus 9? 25, right? And 5 into 5 is equal to 25. So I got this 25 from where? From 5. So in that we just have the 5, like this is the 5 and we just got the first, and the same in only we just have to opposite this, opposite the opposite the same finding array. Like what we have to find, we just have to find uh, uh, previous is 3 into 3 and 4 by 4. So just we change 4 into 4 is equal to 16 plus 3 into 3 is equal to 9 and or 25, and again 5 into 5 is equal to 25. We got this. So in that if we analyze the first and the first approach, which is the very easy approach, like all whenever we just have to try to solve the problem, then we just have to go on the brute force approach, and there is no any time constraint because it will take a lot of time. Like we can use the order of n square, order of n cube, right? So we just have to first use the brute force approach. And what is the brute force approach? Like firstly we just have to traverse the three array. For one is the a square, second is the b square, and third is the c square. So just first we have just traverse the whole array. Int I is equal to, from starting from the 1, not from the 0. So I is equal to 1 2 and I plus plus. This is for a, this is for a. Now int j is equal to 1 and j greater than is equal to and j plus plus, sorry, and this is for b, right? And again int I is equal to int k is equal to 1 and k is equal to and and greater than is equal to, sorry, k is equal to plus plus, right? So this is, and for c. Now we just have to calculate this all right. So nothing, just nothing do here. We just start from the first index, and the first index is like if if array like start like we just have to uh square this two, and then is equal to the third one. So the first square like I into I plus j into j is equal to c into c. If we get this, then count plus plus, right? And at the end return count. So we just have to check. Oh sorry, there is a problem, like uh, we will not assign the count, and also the problem is c. Like we don't have the c, there is the k. You can use their k, and also their int count is equal to uh, 0. So I think now it will run correct for the brute force approach. Yes, it will run correct. And then yes, correct one. Now this is the brute force approach. So that is good, but now can we optimize? Yes, we can optimize. No need to uh, no need to write this all, right? uh, no need to write the three loops. We can solve the same problem using of two loops. How? So we'll see how. Like starting from here, right? Starting from here, like first one is first like n is equal to 5. So in that 1 2 3 4 and the 5, right? So first we have to find like 3 into 3, right, is equal to 9. uh, and 4 into 4 is equal to 16. Now in that 3 into 3 9 plus 16 is equal to 25. And what is the square root of this? What is the square root of this? The square root of this is what is the square root of uh, this one? That means 25. The 25 square root is 5. So can we get the 5 in that loop? Yes, we can get this in a 5. So if we get this 5, then the simple approach and uh, that is a very simple, like c, we just have to find the c into c is equal to 5 into 5. So 25 means we can get this. So that is the very easy, that means we not need to write the three loops. We can same problem we can solve in the two loops. That means optimize approach. So what is this? Same in count is equal to 0, and like start from the I end I is equal to uh, first, and I greater than is equal to n, and I plus plus also. Sorry, that is the problem one. That is the 4, and also uh, 4, sorry, 4 and j is equal to I plus 1. Why we can take from I plus 1? Because of unique. We did not take the same constants, that means same array with it twice. That means a duplicate. So for that reason we can start from the I like 1 first index, and the j first plus 1. That means next one plus after the first one. So in that I plus j, so j greater than is equal to and j plus plus, right? Now in that we just have to first we have to write the answer, and the int answer is equal to what is the value of answer? Answer is equal to simple, what is I into I plus j into j, final one. Up now is nothing, we just have to we nothing to do here. We just have to the simple. If we try to, yeah, that is simple one. Now in that we just have to take int c is equal to, we just have to find the thing. So what is the square root of this? The square root of answer, right? The answer square root is 5. We can get the 5, which means 3 into 3 plus 4 into 4, right? Now we just have to, if she into c is equal to answer, and there is the one constraint. The constraint is we just have to find, this is, that means the c is under the 5. If yes, then otherwise not. So in that, hmm, c and c greater than is equal to, and not more than. And in that we just one more, uh, one more interesting part here. Like we cannot increase the count only one, we can increase the count two, why twice. Like if we can use this, then same thing here we can use this, which means we just have to, this 4 replace to this 4, and this 3 replace to the this 4, this 3. So the same, so for that we can increase the count of twice, and then return count. See if run correct. What is the problem? Oh, sorry. The problem is that, yeah, now it is correct. Yes, and so it will take the order of n square, right? That means it is optimized approach. Yeah, so that's all. So thank you for watching to this video, and please subscribe and write a comment to, uh, how is my approach, and how I explain you got, or what I have to improve to explain that you will get very well, you understand very much clear. Yeah, so that's all. Thank you.